Hey guys, today we're going to look at the Case 21 review. We're just going to look at 1 through 20 in this video, and then there will be a second video for the last half of the Case 21 review. So when you're taking your Case 21, remember that you have to take it during your class block. It will not be open after school. It is only open during your class block. So if you don't know what block you're in, you need to contact your teacher. She should have already contacted you by now, though. So when you're taking the Case 21, use any knowledge that you have, whether it be calculator knowledge or writing stuff out by hand or whatever you can do to solve these problems. If you have a calculator shortcut, use a calculator shortcut. Whatever you need to do to solve these problems, go for it. So for this first one, the expression 80 times 120 can be rewritten as 100 minus 20 times 100 plus 20, which expression, is also equivalent to 80 times 120. So this is a weird way of writing a difference of squares. Difference of squares. Where you have the same number on both sides, but one of them's going to be minus and one of them's going to be plus. That's a difference of squares. So when you're doing a difference of squares, you can just remember that those two numbers have been squared. So that's 100 squared, and then 20 and 20, that's 20 squared, and then you got a plus and a minus. A positive times a negative is a negative. Now you could FOIL this out in the middle. You would get 20 times 100 and minus 20 times 100, and they would cancel out. That's why I only did these two parts of FOIL. So this one's going to match A. However, there is a shortcut to this. All you really need to do are plug these into your calculator and see which one of them equals 80 times 20. So we need to see what 80 times 20 is. So 80 times 120, is 9,600. So we just plug in the other answer choices and see which one of those are equal as well. For A, we have 100 squared, parentheses, minus 20 squared. That one matches, so we know A is our answer. You can also check the rest if you're not sure. B is 100 squared minus 2 times 100 times 20 plus 20 squared. That one's 6,400, so that's not right. C is 100 squared plus 2 times 100 times 20 minus 20 squared. That one's 13,600, so that one's not right. And D is 100 squared plus 20 squared, and that one is 10,400, so that one's not right either. So if you didn't know what else to do and you couldn't think of any way to solve these problems, try doing them in your calculator. Your calculator will actually help you a ton on these problems. So this is the only one that was equal to 80 times 120. So you can FOIL it out, or you can just do your calculator. Okay, for number 2, the x-intercepts of the quadratic function are negative 4, 0, and 5, 0, which could be the equation of the quadratic function. There are a ton of ways to solve this. One of the ways we showed you in class was to make these x equals and get your number back over with the x so that we could make those factors. How you do that is you do the opposite. The opposite of minus 4 is plus 4, so that would be x plus 4. Opposite of positive 5 is minus 5, so that would be x minus 5, and that would match B. You could also just solve all of these for x if you wanted to do that way. Or you could plug each one of these into your calculator. So x plus 4, x minus 5. Take your answer choices, put 0 in y2, and do second trace 5, and see which ones would give you the correct answers. See which ones would give you -4 and 5. Whichever way you do it, you're going to get B.
Third lunch, orange, grab and go. Third lunch, orange, grab and go.
Okay, for number 3, what's the solution to this equation? So we just have to solve for x, just a basic solving for x. So the first thing we can do, we can't do anything on this side because this one has an x and this one doesn't. But on this side, we have this parentheses, so we can distribute this. So 1/2 times x is 1/2 x. 1/2 times 2 is 1. And then you have your option. You can move your x's together and move your numbers together. So we could subtract our 1/2 x over second. So 5 over 3 minus 1 over 2. You can do that in your calculator, and it's 7 over 6. Then you can add your 6 over. So 1 plus 6 is 7. Then you can either divide out your fraction or multiply by the reciprocal. Which would just give you 6. The other option you have here for this step is you could cancel out those fractions by doing a least common multiple. Y'all should have learned this in middle school. They might not have called it least common multiple, but basically just take your bottom, the denominator of your fractions, see what those multiply up to, which is 6, and multiply 6 out. So 6 times 5 over 3 is 10x. 6 times -6 is -36. 6 times 1/2 is 3x. And 6 times 1 is 6. So if you get rid of the fractions that way, you can deal with normal numbers and not have to worry about fractions. And then you still do the same thing. Subtract your 3x over, and then add your 36 over, which is 42, and divide your 7, and x is still equal to 6. So regardless of how you decide to solve this problem, you're still going to get 6. Okay, 4. What's the sum of these two quadratics? So this is just combining like terms. So anytime you have parentheses you want to distribute, a positive times a positive is not going to change anything. A positive times a negative is not going to change your negative. A positive times a negative again is still negative. So none of that's going to change. So we can just go ahead and combine like terms. So you got your x squareds. 3 plus 4 is 7x squared. Then you got your x's. 3 minus 5, because it's plus and negative, which is minus, is -2x. Then your numbers. -1 plus a -6, so -1 minus 6, is -7. So that'll give us C. Okay, number 5. The graph shows the linear functions f of x and g of x. So you got some lines here. It's not scrolling. 1 second. Which point represents the solution to the systems represented by those two lines? The solution is where they intersect. So you just want to figure out what point that is. They cross right here. So what is this point? So remember, it's always an XY point. So we do our x-axis first. And it goes left 3, so -3. And then it goes down 2, -2. So x is first, then y, which is going to be B. Okay, number 6. The equation y equals 50,000 times 0.77 to the t models the population of a colony of bees that is collapsing where t is time in weeks. Which statement is true? So the population does not follow an exponential model. All of these say does not follow or does follow an exponential model. Is this equation exponential? Yes. Anytime your exponent is at the top, that's exponential. So these do follow an exponential model. So A and B are out. So we need to know, does it follow an exponential model because the number of bees decreases by a constant percent, or because the number of bees increases by a constant percent? Look at your multiplier, 0.77. Is that a growth or decay factor? Growth factors are going to be greater than 1. Decay factors are going to be between 0 and 1. So where does 0.77 fall? Right, that's going to be between 0 and 1. So this is decay. So it decreases, which is C. Number 7. A school charges an athletic fee for students participating in sports to cover uniforms and transportation fees. The table shows the relationship between the number of sports played and the athletic fee. If S is greater than 0, so we can't have negatives, so your sports have to be positive, which equation represents the athletic fee, F of S, as a function of the number of sports that a student plays, S? So basically, find your equation. These are all linear equations. So for a linear equation, you need to find your slope and your y-intercept. How do you find slope on a table? You subtract up. So 116 minus 94 is 22. 94 minus 72 is 22. 72 minus 50 is 22. And do it on the other side. 4 minus 3 is 1. 3 minus 2 is 1. 2 minus 1 is 1. So rise over run, y over x. 22 over 1 is just 22. So that's your slope. That's going to go with x, or in this problem, s. So just knowing our slope, this has the wrong number with s, and so does c. So we're down to A and D. We need to figure out our y-intercept. Where do you find the y-intercept? We find it at 0. So your problem does say S has to be greater than 0. That just means your kids have to play a sport. The student has to play a sport in order to be charged a fee. Your y-intercept is still at 0. That's never going to change. You have to find 0. So we subtract up 1 over here to get 0. So on the right side, we subtract up by 22. 50 minus 22 is 28. So all we have left is A and D. Which one has a y-intercept of 28? A. Perfect, because D had 1. had your number for 1, not the y-intercept. Okay, number 8. A landscaper creates a pattern out of bricks. The equation b of n equals 8 times 2 to the n represents the number of bricks in the nth layer. What does the value of 2 represent? So for our exponential equation, what is this 2? First of all, that's your multiplier. You know that because it's connected to the n. So, is your multiplier just going to be the number of bricks in the first layer? Now, if you look up here, the number of bricks in the nth layer, that's represented by n. We don't have a number for n, so we're not looking at the layers here. Same thing for b. This is not the second layer. The layers are n. 2 is your multiplier. It is not n.
Third lunch, blue diamond. Third lunch, blue diamond.
Is it the number of bricks being multiplied by 2 for each consecutive layer? Yes, literally because that's your multiplier. So every single time you make a new row, so you're starting with 8, after that you're going to multiply by 2. Then you're going to multiply by 2 again, and so on and so forth. So that's your multiplier. You're multiplying by 2. So C. And then that 8, that's your initial. It's not what it's being multiplied by. Okay, number 9. A student wants to describe the function graphed on the coordinate plane. So which characteristics describe this function correctly? All of your answer choices here ask for the slope and the y-intercept. How do we find slope on a graph? Rise over run. The best point to start with is going to be your y-intercept, and then pick one more point. So I'm actually going to go with the x-intercept on this problem. Just find another point and use that. So my rise is going to go down 5, so negative 5, and my run goes over 3, so rise over run is negative 5 over 3. So just knowing my slope, I can eliminate some answers. A has negative 5 over 3, B has negative 5 over 3, C and D have it upside down. So C and D are out. Then what's your y-intercept? So it crosses the y-axis as 0, negative 5. So that is A. Number 10. In order to solve the equation 2 to the x equals 8, student graphs the equations y equals 2 to the x and y equals 8. What is or are the solutions to the equation 2 to the x equals 8? So you have a couple options here. You can figure out how many times you would have to multiply 2 to get 8. Or you can do what the student did, and you can graph these. So you can do 2 to the x power and 8. And we want to find where they cross. So we're going to do second trace 5. Find that intersection. And then your phone calculator is going to be slightly different, so just follow the directions on the screen until you see the word intersection. So to get to 8, we're going to have to, that x is going to be 3. So C, x equals 3 only. And that's because 2 to the third power is 8. That's 2 times 2 times 2. That gives us 8. Okay, number 10. A scientist stuffs 400 grams of radioactive substance. 1/4 of the substance decays each hour. Which equation can be used to find the number of hours it takes for the amount of substance to reach 225 grams. So we have 400 grams. So that's our initial. That's what we're going to start with. And then a fourth of it is decaying each hour. When you're looking at a fourth, that's going to be a multiplier. That's going to tell you, decaying is going to tell you that we're looking at exponential. So in our equations down here, we only pick the exponential ones. So that's going to eliminate C and D because those are both linear. Those are both y equals mx plus b. So for our other equations, they're both equal to 225 because that's the total we're looking for. And they both start with 400. The only difference is one of them has a fourth and one of them has 3/4. So how do we get our multiplier? Well, that 1/4 is telling us that we're going to have a multiplier. It's going to be exponential. However, that is not our actual multiplier. Because this equation is asking for how many hours it'll take for the amount to reach 225. So it wants to know how much would be left over or how much is remaining after so many hours. This 1/4 is how much decays, how much goes away. That's the opposite. So we need to know the leftover. So if you split a circle up into fours, one of those fours is going away. So how much is left over? How much is remaining to get that 225 grams? 3 of those 4. So our multiplier is actually 3/4. So B. Just watch what the question asks for. The question wants to know how long or how much is left over, how much is remaining. The 1/4 is what goes away, so it's the opposite. Watch what the question asks for. Okay, 12. Nope. Yep, okay. So this person uses the linear function f of x equals 14.9 minus 0.12 x to represent the relationship between the speed of a baseball pitcher's fastball, x, in miles per hour, and the pitcher's ERA, which is the average number of runs scored against the pitcher in the game. And that's in runs. That's your f of x. So what's the meaning of the slope? So your slope in this equation up here is the one with x. So that's going to be your negative 0.12. And then your 14.9, that's your initial, your y-intercept. So we want to look at slope on this. To do slope, to figure out what it's talking about, you need to know what your rise over run is, what your y over x is. Your x is in miles per hour, so that's the bottom. And your y is your runs, so the average number of runs that the pitcher has. So this negative 0.12, to make it a fraction, to make it a rise over run, we just put it over 1. So your y on top, let me get some water real quick, 1 second. Okay, sorry. Your y on top is the runs, and the 1 on the bottom, your x on the bottom, that's your miles per hour. So that negative, what does that tell us? That tells us that it's going down. It's decreasing. So let's look at our questions. For every mile per hour faster the pitcher is, the ERA decreases by 0.12 runs. So for every mile per hour, so for 1 mile per hour, we are decreasing 0.12. Is that true? Yes, we have 1 mile per hour And we're decreasing because it's negative 0.12. So that one's true. Let's figure out why the rest of them are wrong. B says for every mile an hour faster the pitcher is, the ERA increases 0.12. Well, this one's not right because it says increase. Our slope is negative, so it has to be decreasing. For C, for every increase of 1 in the ERA, the fastball speed decreases by 0.12. This one's decreasing, but 0.12 is not your miles per hour. 0.12 was Y. That's your run. So that's why this one's wrong. It has the wrong unit on it. And then for every increase of 1 in the ERA, the fastball speed increases by 0.12 miles per hour. This one again says increases, which is wrong, but it also has the wrong unit right here. So it's wrong in 2 different spots. So make sure you watch your correct units. Okay, 13 is still based off this question. What statement about 14.9 is true? So 14.9 we said was our initial, which is our y-intercept. Because it's a y-intercept, it's going to be y, which is your run, which is your ERA. So we know this has to be the number of runs, or the ERA. And we know it's a y-intercept. So the value of between 14.9 is the x-intercept of the function. Right off the bat, that's wrong because it's not an x, it's a y-intercept. The value of 14.9 is the x. No, we just said it was the y. The value of 14.9 is the y-intercept, correct. It represents the estimated ERA of 0 based on 14.9 miles per hour. So this part is asking you to figure out your y-intercept is 0, 14.9. What is 0? What is 14.9? Remember, x was our miles per hour, and y was our runs, which was the ERA, the average runs. So is this one saying it correctly? This says your estimated ERA is 0. And 14.9 is your miles per hour. Is that correct? No, because 14.9 was our ERA, and 0 would be the miles per hour. So those are backward. The value of 14.9 is the y-intercept. That's still correct. And it represents an ERA of 14.9, so an average run of 14.9. And based on a 0 mile per hour fastball. Does that match our point over here? Yes, that one's in the correct order. So D is our answer. Okay, 14. Which is the graph of y equals 4? So you have 2 options on this. If you remember, we gave you a little anagram to remember, and we called it Hoy-Bucks. So Hoy stood for horizontal lines, have a 0 slope, and those are just y equals a single number. Bucks was a vertical line, so it goes up and down, horizontals across. It's an undefined slope, and that is x equals a number. This one is just y equals a number, so we're going to look at Hoy. This one needs to be horizontal, which is across. So which one of these is horizontal? A. If you don't remember Hoy-Bucks, you can always just graph this. Graph y equals 4 in your calculator, and you can match it to the graph on your paper. It's just a straight line across, so it matches A. Okay, 15. What is or are the solutions to this equation, x minus 2 squared equals 9? Again, you have a couple options here. You can do exactly what we've done in class the past couple days. We want to solve for x, so we can, to get rid of squared, we can take the square root of it. That'll cancel out your squared and leave you with x minus 2. And the square root of 9 is a positive and a negative 3. So you got x minus 2 equals positive 3, and x minus 2 equals negative 3. And then you just solve. To get rid of minus 2, we're going to add. So 3 plus 2 is 5. Negative 3 plus 2 is negative 1. So you can work it out by hand, and that'll give you b. If you don't want to work it out by hand, you can plug this into the calculator. So move your 9 back over so you can get one equation. So minus 9, because you have to subtract it over to the other side. And then you can plug this in. So parentheses x minus 2 squared minus 9. You want to find your x's, so we have to put 0 in y2. And then we do second trace 5. So get this side, go until it says intersection. That one's negative 1. Second trace 5 to get the other side. And whatever the directions say on your screen, just hit enter until you get the word intersection. And that one's 5. So you're still going to get negative 1 and 5. So it's B. (16) The table shows the total possible outcomes when flipping 1 coin, 2 coins, and 3 coins n times. So that's what this is representing. 1 coin, 2 coins, and 3 coins. Just flipping your coins. Which statement is true? So the value of 2 to the 3 times n is equivalent to what? Would it be 6 to the n or 8 to the n? Well, think about your exponents. This is 2 to the 3rd power, and then we got n out to the side. What's 2 to the 3rd power? If you're not sure, we can plug it in. You do 2 and a rooftop 3. That's going to give you 8. So we know this is going to be 8 to the n power. So that'll cancel out a and b. But why is it 8 to the n? Is it because 2 times 3 is 8 or 2 to the 3rd is 8? Well, 2 times 3 is 6, so that's wrong. 2 to the 3rd power, because this was an exponent, that's going to give you 8. So it's going to be D. Okay, the equation P of x equals negative x squared plus 50x plus 500 models the height of the projectile in feet after x seconds. After how many seconds will the projectile reach its maximum? So what is it asking for? It says after how many seconds? Time is always going to be your x. And will it reach its maximum height? What is the maximum on your graph called? That's your vertex. So this is asking you to find the x of the vertex. So we can just graph it in our calculator. So negative x squared plus 50x plus 500. And we're going to have to zoom out to get this. So you can zoom out or you can hit zoom fit, which is 0. They didn't zoom correctly. Let's see. There we go. There's our max right there. So there's our max. So how do we find a max? We're going to do second trace 4. That's your maximum. And follow whatever directions you have on the screen. Mine say left bound, so I'm going to scroll to the left. Then it says right bound. So I'm going to hit enter on the right. Don't care about guess. Skip that. Our maximum is 25, 11, 25. Which part of that maximum do we want? Because it doesn't have a whole point. We want the seconds. We want the x value. That's your seconds. So that one's going to be D. Okay, which 2 points lie on the graph of the equation y equals 6 times 3 to the x? You have a couple options here. The best option would be to plug this into the calculator and look at the table. The table is going to give you all of your points. So I would go to y equals, plug your equation in, and look at your table. So what are, see if I can make this a little small. Okay, so we have the point -2, -1. So -2 on our table does not match -1, so that's wrong. Then we have -1, 2. So scroll down to -1, and that is 2. So B is correct. Then we have 0, 3. If we scroll down to 0, that says 6. So that one's wrong. D says 1, 9. My table says 118. So that's wrong. E says 254. My table says 254. So that one's correct. If for some reason you didn't want to look in your calculator, you could always plug these in. Plug in your x value, so 6 times 3 to the -2, and see what it gives you. So 6 times 3 to the -2 definitely does not give us the y value. It gives us 0.7 if you round it, which is definitely not 1. So that's wrong. If you plug in this one, 6 times 3 to the -1, that one's going to give us 2, which is our y value. So that one's correct. If you plug in C, 6 times 3 to the 0, that one's going to give us 6 if you plug it in. So that's not 3, that's wrong. For D, 6 times 3 to the first power, that's going to be 18, so that's wrong. And 6 times 3 to the second power, that one is going to give us 54, so that one would be right. So you can plug it into your calculator, or you can work it out by hand. I would recommend the calculator, but if you don't want to, you can work it by hand. Remember though, you only have one class block to take this test, so use any shortcut you can. 19. Consider 2 populations of pigs. A farmer raises pigs and starts with 20 pigs. The number of pigs on the farm increases by the average of 6 pigs a year. This problem is linear. If you're talking about increasing by an average of a constant rate, just 6 a year, that's a constant rate of change, which makes it linear. So we're going to do y equals mx plus b. So m is your slope, b is your y-intercept. So what's our slope? How much is it increasing or decreasing? It's increasing by 6. So y equals 6x. How much do we start with? Our y-intercept would be 20. So that's your first problem. The second one says a population of wild pigs in a specific area can be represented by the function p of t equals 15 times 1.26 to the t, where p of t represents the population after t years. So this one gave you the equation. And this, just looking at it, is an exponential equation. So, which one is true? After 6 years, the number of pigs on the farm will outnumber the wild. Or after 6 years, the number of wild pigs will outnumber the farm. So to figure this out, we can just plug in 6. So for our first equation up here, we got 6x, so 6 times 6 years plus 20. If we plug that in, we're going to get 56. For the bottom one, we have P of T, so 15 times 1.26, and your time is 6 years. If we plug that one in, we're going to need a decimal, but if we round it off, it's 60. So our farm pigs are going to be 56. Our wild pigs are going to be 60. So which one outnumbers the other? Your wild pigs are going to outnumber your farm. So that one's going to be B. The reasons C and D are wrong. The number of pigs on the farm will always outnumber the wild pigs. You can always check this one in your graph. That's what I would go to. So this is bigger. So if we plug our equations in, 1.26, and if you graph it, zoom 6. I'm going to zoom out just a little bit so you can see this better. So if you graph it, you can see that this red one, this is our wild pigs. The blue is our farm pigs. So when we start off, the wild pigs have more, and eventually they'll go below the farm pigs, and they'll have less than the farm. But if you keep going, it will rise above the farm again. So it's above it first, it's on top of the blue, but then it's below the blue in the middle, but then at the end it's going to be above the blue again. So at some point, the farm pigs are going to outnumber the wild pigs, but not forever. So your farm pigs will not always outnumber your wild pigs. It's only that one little bitty section in the middle, because it looks like this, if you couldn't really tell. So just this little bitty section in the middle is where your farm outranks your wild pigs. The number of wild pigs will always be the same as the number of pigs on the farm? No. These are very different everywhere. They only cross each other and are the same twice. Everywhere else they're different. So they're never really the same, except for those two little bitty spots. Okay, number 20. A diver jumps off a 115-foot cliff into the ocean. The path of the jump follows the equation h of t equals negative 16t squared plus 5t plus 115, where t is time in seconds after the jump, and h of t is the height in feet of the diver after jumping. What's the most reasonable domain for the function? What is domain, x or y? Domain is x, which in this problem is being represented by t, which is our time in seconds. So what I would do is I would graph this so you can figure out where it's starting and stopping. So negative 16x squared plus 5x plus 115. Ooh, make that better. I'll zoom out just a little bit. It's not going to work. Okay, we just want to figure out where it's stopping. We can figure out where it starts in a second. So where do we hit this x-axis is your ocean. Where do we hit the ocean? So we just have to put 0 in y2. There we go. So figure out where we hit the ocean. It's going to be second trace 5. We want to get that right spot. Where is my cursor? There it is. So our intersection point is 2.84. So that's where she's gonna hit the ocean. Now, I was trying to zoom this so you could see it better, but it looks like this. This spot right here where we start, that's gonna be your y-intercept. That's your 115-foot cliff. And then she jumps off that and hits the ocean, where we just found 2.84. This one's the domain. So where do we start on the domain? We don't start over here at this x value because this is negative. It's actually negative 2.53. The reason we don't start there is because our domain is seconds. There's no such thing as negative time. We don't know how to time travel to the past yet. So we don't get to include the negative part of the graph. This whole part of the graph gets canceled out. We have to start at 0 for time. We cannot go to negative. So we're going to start at 0, and then she jumps off and she hits the water at 2.84. So which domain would this match over here? It would match C. Time has to be positive, well, or 0. And then it goes, she hits the water at 2.84. So that one would be C. So I'm going to stop this video here, and then the second video will pick up back at 21.